Welcome to this tutorial, which is going to look at another use for CHOPS, which is to take animation from a single object and replicate it on a large number of objects while varying it so that each object moves differently. And the example I'm going to construct here is actually drawn from a video on Vimeo called Subprime, which is very popular, which has a sequence of scenes with houses being built and destroyed. So we're going to build our house from planks flying in and erecting themselves in this oblong shape. So first let's view the effect that we're going to try and create. So I've got a house here constructed of a number of planks, and I'll just talk briefly about how that's done. We've got a couple of lines which we use as the basis of some points on which to copy our planks. And the method we do that is pretty similar to the method that's used to construct the brick wall in the RBD series of videos, so I'm not going to go through it in detail. But we create a long line and a short line, and then we merge them together, and then we copy the two lines, transform them, and then merge those together so that we end up here with 4 lines. And if I turn off the grid and display only our object, we can see the lines pretty easily there. I'll turn off the origin no one, and we can see that we have the lines there, and we can enable points, and we copy a plank to each of these points. And of course we have to make sure the points are spaced correctly in order to accommodate the planks. The other thing that we do here is set up some groups, and I start by setting up a group straight after the line is created, and that contains all the points in the short line, and this group here contains all the points in the long line. Then when we transform the points here, the lines rather, we use the edit functionality of the group SOP to create 2 new groups with different names, so that we end up with 4 groups, 1 for each of these lines. Long line group 1, long line group 2, short line group 1, short line group 2. Then we merge everything together, and we use a copy SOP to copy the planks. Just one further remark on the use of these group SOPs here. We're renaming the existing groups because they will still exist on this set of points, but when we merge them together here, we would end up, if we didn't rename the groups, with only 2 groups instead of 4. It's important when you use the rename functionality to turn off your group creation options here on the Create tab. Normally this is enabled, and if you leave it enabled, you'll get an odd result. So we're just renaming the groups here. The other thing I've got is a single plank. Let's turn off the view of our house, and I've applied some keyframed animation to it. The single plank is just being merged in from our house plank, which is just basically a box, and I've applied some keyframe animation so that as the scene progresses, the plank flies in and sticks itself into the ground at the origin. And what we want to do is use this animation as the basis for animating all of the planks that make up our house. The first step to achieve that is to bring in our rotation information, and I'm going to do that by appending after the merge here an attribute create node, and I'm going to call the attribute we're going to create R, and I'm going to make it a 3-valued float attribute. And then for the value, I'm going to use a channel expression, which just fetches the value of another parameter to bring in the rotation values from our single plank animation. So that's the X component of rotation, and I'm going to just copy that parameter and paste the copied expression into the other values of our three-valued rotation, and then go back and edit this so that it's RY and RZ. And I'm going to rename this something memorable, like a trim rotate. The next thing we need to do is bring in the position information. And we're going to need to do this separately for each of the groups. So let me append a point SOP. Let's put the display flag on it. And let's limit its effect to the long line group 1. And we can see we've got position information here. And we've got these variables tx, ty, and tz, and they're the existing position of the point. And we want to add the animation to this. Our animation is relative to the origin. The plank flies in and sticks itself at the origin, whereas our individual planks need to land at the points here. So we need to offset these points by the animation rather than replacing them with the animation. Let's try this. I'm going to try adding in the channels using the channel function again, and we're going to go to Object, Single Plank, TX, and this time I'm just going to select that function and Control C, and then for the Y value we're going to plus, Control V to copy that, and go back and change that to TY. And for Z, Control V again, and TZ. So this now means that the points of our long line group are being offset by the animation. So let's see what that looks like when we bring it in, and we can see all the points fly in at once. So let's rename this point long line 1, and then I'm going to copy that node and paste it, and I'm going to connect it in like so, and I'm going to call this point long line 2, and we're going to use the second group as well. In fact, it's got a different name, so let's delete that. And what happens now is that both of these lines fly in from the right of the screen, whereas what we of course want is for the left-hand line to fly in from the left of the screen. So we're going to need to edit this slightly, and we can see that we want to do something with the Z coordinate of the animation. And in fact, if we take away the animation instead of adding it, then it works like so. And I'm going to Control C, Control V, and copy this again. And this time we're going to look at the short line group 1. So let's rename that. And this time we're going to have to do something more sophisticated, because we want the animation to be relative to the X direction. And at the moment most of the animation is happening in the Z direction. So we need to swap Z and X. So I just need to edit this and make this Z, and then in the Z direction we need to make it X. And let's see whether that works. And as we can see, those are all flying in from their respective directions. And finally, Control-C, Control-V one final time. Select the short group number 2. And in this case we're going to have to reverse the animation in the X direction. So let's do that. And we should find now that all of the lines fly in together. And we can connect the output of this into our copy, make that the display, and we can see now that 4 walls fly in and arrange themselves. But what we want to achieve is for each individual plank to fly in separately. And to do that, we're going to have to use CHOPS. So let me add a null to the end of this chain here, and I'm going to call it 2CHOPS. So now we need to create a CHOPS network. So I'll lay down a CHOPS network, and I'm going to call it replicate anim. And let's dive inside. The first thing I need to do is bring in all that information we have now on our points. And to do that, I'm going to use a geometry chop. First thing I need to do is to select where we're going to get that information from. And we're going to get it from the 2CHOPS null that we just laid down. And by default this brings in the position information and creates channels TX, TY and TZ. I also want to bring in our R attribute, and I'm going to call those channels RX, RY and RZ. And if you remember from the earlier videos on CHOPS, there are 2 ways in which the geometry chop can work, one of which is static. The one we want is animated, and that creates a channel for every point at every one of these attributes. So we end up with a very large number of channels, 248, or rather 288, and at the moment they're ordered so that we have all the translate X channels first, and then probably the translate Y, translate Z, and so on. And that's going to be a problem for us, because what we would prefer to have is TX0, TY0, TZ0, RX0, RY0, RZ0, and then TX2 and so on, or TX1 and so on. We want an arrangement whereby each point's attributes are grouped together. So we have all of the attributes for point 0 and all of the attributes for point 1 and so on. Well, fortunately we can do that using a reorder chop. And a reorder chop allows us to sort by numeric suffix. So this is now sorting by the number that appears at the end of the channel names. So we should find now, here we are, that we have RX0, RY0, RZ0, TX0, TY0, TZ0.